Today we're going to demonstrate why clays can be a challenge in mining operations. So here I have 3 ores, and in these ores I have the exact same amount of my valuable product, which you will find out what that is in a moment. I also have varying amounts of our clay representative. In this case we're using proxy, which is this quackar puck. So we have the same volume and mass of our 3 ores, and we have the same volume of water in all 3 cases. So I'm just going to go ahead and add the water to my ores, and we're just going to watch what happens. So the first thing we notice is that we do get some liberation of our valuable product, in this case our Lego cubes. This would represent bitumen or something else that you would typically separate out by flotation. We've easily able to separate out some of this. This one is a little more challenging to separate out. We're starting to get some clay into the water, making it a little harder to separate. And you can see that the volume of my sediment is also increasing as the soil puck expands and absorbs water. And again, we have some good liberation of my Lego here, and some where it's a little bit more difficult to get to. Again, a little bit of that contamination. In all 3 cases, I did put the same number of blocks, so 6 cubes. So we can see with this sand only, the volume of the sand really hasn't changed significantly when we added the water. When we have pretty clear water, that's going to be easy for us to separate out. In this one, we have a fair amount of expansion, and we have some nice clear water and some on the top that's going to be a bit of a pain. And then in this one, this whole area has really expanded significantly. It's about 2 or 3 times the volume here. So this is without us doing any mechanical agitation or anything that would make separation more difficult. Now I'm going to just do that separation. So I'm going to disperse my sample, see if I can get that last cube out, and I can easily do that with the sand. And my water is now fairly clear. I can pour this back out. This I'll be able to recycle to use as another separation, and I'm left with a volume of sand. Almost the same as what I started. I'm going to do the same with this one. Oh, and see now my water is just very dark. I do get some separation, but it's harder to find. And I'll probably need to do an additional washing step to get the product clean of those clays. And that's, again, very typical of when you have a lot of clay in your sample. It's so dark, it's hard for me to see whether or not I actually have any of those valuable products left. Oh, there's the last one, haha. But that water is very difficult. I can separate it out. We'll pour it off. Volume is now higher than the original, and the water that I've recovered is very dirty. It will require significant amounts of time to let that settle and clear up before it can be recycled, or additional water treatment. Final one, trying to stir it up, get that recovery. We were able to get the recovery. I'm still missing, I think, 1 block. I can pour that water off. It's very thick and goopy. There's going to be more sludge there, and again, a lot more volume that we're recovering. This just demonstrates exactly what happens when we have varying amounts of clay in our deposits. And of course, this is also very true to life in that initially they all looked the same. So we knew we had some valuable product in there. We didn't know if there was clay. We don't know how much clay. It's often difficult to measure that before we mine it. This is what happens if you think you have something like this, just that pure sand, and you make your process around having that nice separation. You know you can recycle this. You don't need a lot of extra steps. But when you have that extra clay that comes in, you're probably going to need a lot of extra steps, a lot of extra water, and it's going to make a big mess.